Okay, so continuing, more laws of exponents. Let's see what happens if we were to do something like x squared over x squared. Well, that's kind of silly. We know that this should end up just being 1 because we're taking a number divided by itself. But let's think about this another way. If we use that first law of exponents that we saw in this chapter, or in this section rather, this one said a to the r over a to the s is equal to a to the r minus s. Oops. That's r minus 2. Should be r minus s. Okay. So if I did that, I would get x to the 2 minus 2, which is x to the 0. And whenever we're doing these rules, it shouldn't matter which rule we're following. As long as we're following that rule correctly, as long as everything matches up in the pattern and we follow the rule correctly, these shouldn't change the result. So this actually, if you follow these equal signs, this should be an equals as well, I suppose. If you follow these equal signs, we get 1 is equal to x to the 0. And in general, if we raise a number and raise it to the power of 0, we're going to say that is equal to 1. Now this seems a little odd to people when they first see it. They feel like this should be equal to 0 because this is nothing. But the question here is, what nothing are you talking about? Really, we should be talking about the nothing. The identity is the actual technical name of multiplication, the multiplicative identity, which is 1. Let's just look to see how it fits into the pattern. If we had x, let's do 2 to the first, 2 squared, 2 cubed, 2 to the fourth, and so on. If I was to just look to see what these numbers are, well, 2 to the first is 2, 2 squared is 4, here we get 8, here we get 16. Each time we're going down in this, as we're increasing our power by 1, we're doubling the number. And if I'm going the other way, if I'm going from 2 to the fourth down to 2 cubed, I'm going to be cutting it in half. I'm going to be dividing by 2. The same thing goes here. I'll divide by 2 to get to there. And the same thing should go here. If I get 2 to the 0, I'm decreasing my power by 1. I should be dividing by 2, which gives us 1 here. And a quick little brief glimpse of what we're about to get into. If I was to continue this pattern, well, if I divide by 2, I get to 1/2, or 2 to the negative 2 should be, well, divide by 2 again, I get 1/4. We're about to see this in one of the upcoming slides as far as, kind of where this comes from, or what the actual law of exponents is. But this just kind of shows you how this all fits into the same pattern. All right. So in any case, we had a to the 0 is 1. In this case, in this example, we have a big blob of stuff all raised to the power of 0, so it's just 1. On this one, you'll notice that x is the only thing that's raised to the power of 0. So this part right here goes to 1, but everything else stays put, so we get 3y to the 0. If we raise the x to the power of 0, this is the exact same thing as saying we have, well, in general, when we're raising a variable to a power, that's saying the number of copies of that variable we have. We have 2 copies of this y. This is 3 times y times y. But since this is x to the 0, that's saying we have 0 copies of the x, which means it's kind of silly to write it in there, So you get the same thing if you just leave it out. We get 3y squared.